Hello learners, welcome for today's revision lesson. Today we are going to revise a question on photoelectric effect. I believe you've gone through the topic thoroughly, and now we want to look at a question here. The question reads, the work function of a clean metal surface is 4.5 electron volts. Calculate A, the minimum frequency of radiation that will cause emission from the surface. B, the maximum energy of electrons emitted when the surface is illuminated with a radiation of frequency 1.2 times 10 to power 15 Hertz. So, in the first question, we are meeting the term minimum frequency. This minimum frequency is the same as what we are calling the threshold frequency. Threshold frequency is defined as the minimum frequency of a radiation below which no photo emission occurs. Let us now embark on solving the first question, part A, getting the minimum frequency, that is the threshold frequency. So we are given the work function, which is W naught, to be 4.5 electron volts, and we are looking for this F naught, which is the threshold frequency, that is the minimum frequency of the radiation. We know that work function is given by the following formula: Planck's constant times C. This C here is another constant. It is the speed of the electromagnetic radiations in vacuum, and then you can divide by lambda naught. Or work function can also be given by Planck's constant times threshold frequency. So this is the formula we are going to use, because as you can see, it has got the threshold frequency, it has got the Planck's constant is a constant, will be given, it is a constant, it is provided, or we just know it. It is 6.63 times 10 to power negative 34 joule seconds. So I'm going to use this formula to solve this question. Another thing, work function is given in form of electron volts. I cannot use this work function in this unit here in this equation, even in this equation, not unless I convert it to joules. So when converting into joules, I'll first of all do this. 1 electron volt is equal to 1.6 times 10 to power negative 19 joules. Therefore, 4.5 electron volts will be what? It will be 4.5 times 1.6 times 10 to power negative 19. My answer here will be in joules. This one will give me, from my calculator, I'll just have to multiply 4.5 by 1.6, then I'll come and harmonize the power later. So according to this my calculator, 4.5 multiplied by 1.6, that is 7.2. So I get 7.2 times 10 to power negative 19 joules. So this is the work function now in joules. Remember, we are given work function in electron volts. We've converted our work function now here to be this in joules. Now I can substitute in this equation. I'm using this equation because I'm looking for F naught. Suppose the question would have asked us to get the lambda naught, I would have used this equation. But this time I'm just reading this equation here. So 7.2 now becomes the work function in joules. So I'll have substituting 7.2 times 10 to the power negative 19 being equal to the work function, the Planck's constant is 6.63 multiplied by 10 to the power negative 34 joule seconds multiplied by F naught. So I need this F naught. Divide both sides by 6.63 times 10 to the power negative 34. 6.63 times 10 to the power negative 34. So once I have that, this one will cancel, so that I'll have my F naught this other side. This other side, I'll have 7.2. I just divide it by 6.63. The answer I get, so I have 10 power negative 19, 10 power negative 34. This one becomes 10 power negative 19 minus negative 34. When multiplying numbers of the, when dividing numbers of the same base, you simply subtract their powers. So I divide this one, 7.2 divided by 6.63. When you do that, you get 1.086. It will be times 10. When this one is worked out, negative becomes a positive. So we have negative 19 plus 34. It becomes 15. This one is equals to F naught. So the minimum frequency required here is 1.086 times 10 to the power 15 frequency, meaning hertz, the units. That is the answer to part A. That is the answer to part A. You can follow through. This one was work function in electron volts. We are looking for threshold frequency. And I gave two formulas here for calculating work function. Work function can be gotten using this formula or this. The most appropriate in our case was this one. So I substituted I used this equation now to solve. And before I could use this equation, I first of all changed the work function given here in joules. It was given in electron volts. That's what I was doing here. I was converting the work function in joules now. So it is no longer in electron volts. Then I substituted in this equation. So work function, it was this one, equal to Planck's constant, this one, then F naught, this one. I divided both sides by the Planck's constant, as you can see. Then this one yield 1.086 times 10 to the power 15 hertz. So this is the minimum frequency that will cause photo emission to occur from that surface. We go to the second question. Part A. That is the answer to part A. You can follow through. This one was work function in electron volts. we are looking for threshold frequency, and I gave two formulas here for calculating work function. Work function can be gotten using this formula or this. The most appropriate in our case was this one, so I substituted I used this equation now to solve. And before I could use this equation, I first of all changed the work function given here in joules. It was given electron volts. That's what I was doing here. I was converting the work function in joules now, so it is no longer in electron volts. Then I substituted in this equation. So work function, it was this one, equal to Planck's constant, this one, then F naught, this one. I divided both sides by the Planck's constant, as you can see. Then this one yield 1.086 times 10 to the power 15 hertz. So this is the minimum frequency that will cause photo emission to occur from that surface. We go to the second question, the second bit. In this case, we will get the energy of the radiation. Energy of the radiation is given by the formula E is equals to H F. Well, this is the frequency of the radiation, this Planck's constant. So first of all, we get the energy of the radiation. Energy of the radiation is given by that. H is 6.63 times 10 power negative 34. I'll multiply by the frequency of the radiation, which I'm given to be 1.2 times 10 power 15. So this one will give me the energy of the radiation, and that one becomes just multiply. I'll multiply this by this, then these powers I'll work them later. So 6.63 multiplied by 1.2, we get 79. That is 7.956, of course, times 10, because we are multiplying numbers of the same base. What do we do to their powers? We add their powers. So this one becomes power negative 19. So this one is joules. This is the energy. This is the energy of the radiation. But we wanted the maximum energy of the electrons. Remember, when an electromagnetic radiation is irradiated on a metal surface, it will dislodge electrons from the metal surface if the energy of the radiation is equivalent to the work function. So I can write this equation that energy of the radiation is given by work function plus kinetic energy. So if this energy is enough, it will dislodge the electron from the metal surface, and there will be another extra energy that will take care of this one. So this one is what will enable these electrons that have already been dislodged to the metal surface to be emitted away. So this is what we are looking for. So kinetic energy from this equation is given by energy of the radiation minus work function. Energy of the radiation we've calculated to be this one. So it is 7.956 times 10 to the power negative 19. I subtract. Remember, the work function we had converted somewhere, and it is this. This is the work function. So I come and subtract this value. So I come and subtract 7.2 times 10 to the power negative 19. These ones are values of the same power. So what I'll do, this is the same as 7.956 minus 7.2. Everything is by 10 power negative 19. So I just subtract these two, which will go to 7.956 minus 7.2, I get 0.756, of course, times 10 to the power negative 19. It is not in standard form, so this decimal moves this other side. It becomes 7.56 times 10 power. Because here I'd moved one step this backwards, it is negative, so I come and add -1 here. I get -20. And because it is energy, the value is in joules. So that is the energy, that is the maximum energy of the electrons emitted when the surface is illuminated with the radiation of a frequency 1.2 times 10 to the power 15 hertz. Thank you for watching and welcome in the next video.